In this module, we're going to look at how to choose the right indicator and how do we help our students understand why we use certain indicators and what they're actually representing and what they're telling us. In this module, we're going to look at how to choose the right indicator and how do we help our students understand why we use certain indicators and what they're actually representing and what they're telling us. So choosing the correct indicator is crucial in acid-base titrations because we need to be able to match the pH range that we are expecting in those reactions. Where if we choose the wrong indicator, then it means that we won't be able to ensure precision and accuracy. And we also want to make sure that we're avoiding over-titrating or under-titrating. That is adding too much or too little of our titrant to the analyte. Choosing the correct indicator is crucial in acid-base titrations because the indicator serves as a visual signal to determine the endpoint of the titration. So remember that the endpoint is the point in the titration at which the amount of titrant added is stoichiometrically equivalent to the amount of analyte. So there's some really important considerations we have to make when we are choosing an indicator. So the first is matching the pH range. So different indicators have different pH ranges over which they undergo that noticeable color change. It's essential to choose an indicator whose pH range corresponds closely to the pH change that occurs during the titration. The indicator's color change should coincide with the equivalence point of the titration for accurate results. If we choose an indicator that is not close enough to the equivalence point, then the endpoint is going to change. We're going to have that color change, and we're actually not going to get accurate results because it's going to change at the wrong time. So we need to make sure that we're picking one in which the endpoint is going to change around about the same as the equivalence point occurs. A well-chosen indicator provides a really sharp and distinct color change, and this helps us with precision and accuracy. For example, in a strong acid, strong base titration, a universal indicator or phenolphthalein might be suitable to use. However, universal indicator, because of the gradient of colors, may be chosen not to be used. And phenolphthalein might be chosen over that because phenolphthalein gives a really sharp color change from clear to pink at the endpoint. In a weak acid and strong base titration where pH change is more gradual, a more sensitive indicator like bromothiamyl blue might be preferred. If an indicator has a pH range that extends beyond the equivalence point, there's a risk that we might over-titrate the solution, resulting in excess titrant. Or, on the other hand, if the pH range is too narrow and the color change occurs abruptly, there's a risk of under-titrating, leading to an inaccurate determination of the endpoint. And so all of these factors come into play when we're trying to choose the right indicator. It's important in titrations because titration is not your run-of-the-mill measuring. It is an accurate, quantitative way to collect data, and we want it to be as accurate and precise as possible. And that's important to convey to your students as well. So here is our pH scale. We know that our bases or our alkaline substances have a high pH, so from 8 to 14. We know our acidic substances have a low pH from 0 to 6. If we have a strong acid, it's going to be down towards that 210 end of the pH scale. If we have a strong base, that's going to be up our 12, 13, 14 end of the pH scale. And in the middle, we have our neutral. Now, here is a diagram that is showing us the different types of indicators we can use for the different types of acids. And I want you to really think about and get your students to really think about what is reacting. So if we have a strong acid, and so a strong acid is going to have a very low pH, and we have a weak base, and that weak base is probably going to have a pH maybe around 9 and 10, okay? And we've got that with our strong acid. Then if we're putting the two of those together, and we're getting to a point where they've got equal-ish amounts, then we're actually going to end up with an end point that is down towards the acidic end. Okay, so it's going to be somewhere between, if we have a strong acid, it's going to be somewhere between maybe 2 and 4, maybe that we're expecting that, maybe 2 and 5. So the types of indicators that we can use for a strong acid and a weak base is going to be cresol red, and that's for a really strong acid, and thymol blue. It says first change here because thymol blue actually has a second color change a little bit later on. So you can see the second one down here. So it has a color change from red to yellow or orange here. And that has another one into blue a little bit later down the track. But if we have a strong acid and a weak base, we're expecting the sort of average them out is going to end up in this little area here. Now we can also use something like bromothymol blue. Okay, so again, we've got a strong acid, maybe a little bit less strong than the two here previously, a strong acid and again a weak base. And so we have a nice endpoint here around the 4 to 5 mark on the pH scale. Our methyl orange, same sort of area as our bromophenol blue, and also a bromocresol green. Methyl red, again, another one we can use for a strong acid and a weak base. And we want this endpoint is somewhere between the 4.4 and 6.2. Bromothymol blue, that is one that is used more frequently. You can see that this change is between the yellow and the blue. Again, we do have a little bit of a transition in green color sometimes in there. And I'll demonstrate that for you in one of our videos. But here we would use this for a strong acid and a strong base. So if you can imagine, we've got two ends of the scale, so strong acid and strong base. And if we're trying to neutralize them, they're going to neutralize around the 7 pH mark. And so we want an endpoint in our indicator that is around that point. Phenol red, again, a strong acid and a strong base. So you can see here that the endpoint is between 6.8 and 8.4. Thymol blue, okay, between 8 and 9.6. Now this is for a weak acid and a strong base. So now you can see if we have a weak acid that's going to sit up around maybe 4 or 5, and we have a strong base that's sitting up around 14, it makes sense it's going to shift towards the base end a little bit, and so we want an endpoint between 8 and 9.6. And phenolphthalein, okay, weak acid and strong base as well. Now, you might have noticed that we don't have one here for a weak acid and a weak base. And the reason for that is that an indicator is not precise enough to find the endpoint, because the endpoint in a weak acid and a weak base, it doesn't have enough of a zone in order for us to take that endpoint. So the way that you would measure a weak acid and a weak base to find the endpoint would be using a pH probe. So when you're doing the titration, you can just have the pH probe in with your analyte. And as you are titrating, it will, depending on what type of pH probe you use, the new ones, they will basically graph it for you until you'll end up with a graph that you can analyze for the endpoint there. So in the notes I got you to download at the beginning of the course, there's actually a page in there for you to record down what each of the indicators are used for in titrations. And so you can fill those in as to whether they're a strong acid, strong base, or weak acid, strong base, whatever they are, just so you've got a nice record on hand